Have you ever wondered where Earth's water came from? How did our planet, once a fiery and barren rock, develop the oceans, rivers, and lakes that sustain life today? The story of how water came to Earth is as complex as it is fascinating, and it involves cosmic collisions, volcanic eruptions, and the very building blocks of our solar system. Today, we're going to dive deep into the history of Earth's water, tracing its origins back to a time when our planet was very different from the lush blue world we know now. Let's start with Earth's formation. Around 4.5 billion years ago, Earth was born from the dust and gas surrounding the young sun. Initially, Earth was a hot, molten mass, and the surface was inhospitable to life, devoid of water. It was a world of extreme volcanic activity and intense heat, where the atmosphere was thick with gases like carbon dioxide and nitrogen. In fact, there was no liquid water on Earth for a long time during its early history. So, how did Earth get its water? Scientists believe that water didn't come from Earth itself during its initial formation, but rather from extraterrestrial sources. The two leading theories about how water arrived on Earth involve comets and asteroids as well as volcanic activity here on Earth. Both of these theories point to a combination of cosmic and geological events that allowed water to accumulate, shaping the Earth we know today. First, let's talk about comets and asteroids. These icy bodies are remnants from the outer reaches of our solar system, and they contain a lot of water in the form of ice. Scientists think that during the period known as the Late Heavy Bombardment which took place about 3.8 to 4.1 billion years ago, Earth was bombarded by countless comets and asteroids. These collisions were catastrophic, but they also brought vast amounts of water to our planet. As these icy objects crashed into Earth, the ice would have melted due to the heat, releasing water vapor into the atmosphere. Over time, that water vapor would have condensed and fallen as rain, eventually filling the planet's surface with water, forming the oceans, rivers, and lakes. But there's another important source of water: volcanic activity. While comets and asteroids delivered water to Earth from space, volcanic eruptions also played a crucial role in releasing water that was already trapped inside the planet. Early Earth was extremely volcanically active, and volcanoes released water vapor, carbon dioxide, and other gases into the atmosphere. The water vapor would have cooled and condensed as the planet cooled over time, contributing to the formation of Earth's first oceans. In fact, some scientists believe that volcanic outgassing, the process by which water was released from deep within the Earth, may have been a significant contributor to the planet's water, working alongside cometary impacts. Another aspect of this story lies in the chemical composition of water itself. Water is made up of two elements, hydrogen and oxygen. The building blocks of these elements were already present in the early solar system. Hydrogen is the most abundant element in the universe, and oxygen, while less abundant, was still readily available in the gas and dust that formed the solar system. When Earth formed, hydrogen and oxygen were part of the chemical mix that went into creating the planet. This means that Earth's water didn't just arrive from the outside, it was also part of the planet's very formation. A key part of this research is the study of deuterium asterisk, a heavy form of hydrogen. Scientists have studied the ratio of deuterium in Earth's water to understand the origins of our oceans. Interestingly, the ratio of deuterium found in Earth's oceans closely matches that found in the comets that scientists have studied, suggesting that comets played a big role in delivering water to Earth. However, some studies show that volcanic outgassing may also have contributed to this ratio, indicating that both cosmic impacts and internal volcanic activity were essential in the formation of Earth's water. Once the water arrived, the Earth began to cool. The early atmosphere, filled with volcanic gases, created a strong greenhouse effect that kept the planet warm enough for water to remain liquid. As the Earth cooled further, the water vapor in the atmosphere began to condense, forming clouds. These clouds eventually released rain, filling the planet's basins and creating the first oceans. It's thought that this rain, over millions of years, helped shape Earth's surface and led to the formation of rivers, lakes, and seas. The presence of liquid water on Earth was a game changer. Water plays a critical role in regulating the planet's temperature, supporting the water cycle, and creating the conditions necessary for life. In fact, Earth's unique ability to hold water in liquid form, thanks to its distance from the Sun and its protective atmosphere, makes it a rare gem in our solar system and beyond. Without water, life as we know it could not have evolved. So, what happened to all the water brought to Earth by comets, asteroids, and volcanoes? Most of it stayed on Earth, but some may have been lost to space over time. However, Earth's water was recycled through processes like evaporation, condensation, and precipitation, forming the water cycle that sustains life today. This cycle is what allows our planet to support an incredible variety of ecosystems, from tropical rainforests to deserts. The origins of Earth's water are still being studied today, and scientists continue to explore how different processes, both cosmic and geological, came together to make Earth the watery world we live on. What we do know is that the arrival of water was crucial to the development of life and the formation of the planet we now call home. In conclusion, Earth's water didn't just appear out of nowhere. It came from a combination of cosmic impacts from comets and asteroids, volcanic outgassing, and the very materials that formed the planet. Together, these forces shaped our oceans and rivers, allowing life to flourish and evolve. The history of Earth's water is a remarkable journey, one that reminds us of the intricate forces that have shaped our planet over billions of years. Thanks for watching. If you found this video interesting, make sure to like, share, and subscribe for more incredible stories from the history of our planet.